Hey everyone, Mr. Hauk here. In this set of notes, we're going to be looking at the different relationships between our 6 trig ratios. So we've already had our original 3 trig ratios, sine, cosine, and tangent, and in the previous set of notes, the 7.4 notes, we established the reciprocal trig functions, cosecant, secant, and cotangent. So the purpose of this set of notes is to establish relationships between these 6 different trig functions. And we're going to call them the identities, more specifically the Pythagorean identities. But let's go ahead and jump into it. So I'm going to actually skip Calcmedic's front page, their exploration activity, just for the sake of time. I know the previous video kind of ran a little bit long. I'm going to try to make this one not run as long. Okay, so I'm going to jump straight to the important stuff, establishing the trig relationships. So I'm going to split this into 2 different sections with a little bit more space on the right side. So the first thing I want to establish are the basic trig identities. All right. And these are identities that we've already come to establish here. So, for example, another way that we can write sine, since we know that sine's reciprocal is cosecant, sine of theta can also be rewritten as 1 over cosecant of theta. Cosine, since we know cosine is secant's reciprocal, cosine of theta can be rewritten as 1 over secant of theta. And we know that tangent of theta has 2 different ways that it can be written. We know tangent of theta can be written as sine of theta divided by cosine of theta. But we also know, since tangent and cotangent are reciprocals, the tangent of theta can also be written as 1 over cotangent of theta. Okay. Similarly, cosecant of theta can be rewritten as 1 over sine of theta. Secant of theta can be rewritten as 1 over cosine of theta. And cotangent of theta, just like tangent of theta, has 2 different ways it can be written. We can write cotangent of theta as cosine of theta over sine of theta, or we can write cotangent of theta as 1 over tangent of theta. Okay, so these are all coming from those reciprocals that we established in the 7.4 notes. Now the next set of identities, very, very important set of identities, are what we call the Pythagorean identities. Right? There are 3 of them. First one, sine squared of an angle plus cosine squared of an angle is equal to 1. Sine squared of an angle plus cosine squared of an angle is equal to 1. Now, we can rearrange this and actually come up with 2 new identities. If I took this sine squared of theta and I subtracted it to the right side, we would have cosine squared of theta equals 1 minus sine squared of theta. So this is an equivalent relationship, it's just rewritten. And if I took the cosine squared of theta and I moved it to the right side instead, I would have sine squared of theta equals 1 minus cosine squared of theta. Okay, the one that you need to commit to memory is this one. Sine squared of theta plus cosine squared of theta equals 1. So memorize this one. Know how to rearrange this equation to get these 2. Okay? The second Pythagorean identity is going to be 1 plus tangent squared of theta equals secant squared of theta. Okay? And just like the previous identity, the previous Pythagorean identity, we can rearrange this in a couple different ways. I can take this tangent squared of theta and subtract it to the other side. That would give me 1 equals secant squared of theta minus tangent squared of theta. Or I can subtract the 1 instead and get tangent squared of theta equals secant squared of theta minus 1. But again, the one that you want to memorize is this one right here. Okay? The third Pythagorean identity that we're going to memorize goes like this. 1 plus cotangent squared of theta equals cosecant squared of theta. Rearranging, if I subtract the cotangent squared of theta to the other side, I would have 1 equals cosecant squared of theta minus cotangent squared of theta. And subtracting the 1 to the other side, I could have cotangent squared of theta equals cosecant squared of theta minus 1. Again, the one that you need to commit to memory is this one, and then you can just rearrange that one to get the others. Okay? Now, the reason we call these identities is because they hold true for all angles of theta. Okay? So let's write that down. These relationships between the 6 trig functions are called identities because they are true for all theta. Okay. Now, really important detail that I want you to notice. Notice how all of these basic trig identities that we wrote on the left side can all be represented in terms of sine and cosine. Sine and cosine are already sine and cosine. Notice that tangent can be written as sine of theta divided by cosine of theta. Cosecant can be 1 over sine of theta. Secant can be 1 over cosine of theta. And cotangent can be rewritten as cosine of theta over sine of theta. So this is really helpful, especially when we get down to simplifying trig expressions, because it gives us a way to rewrite every single trig expression in terms of sines and cosines. And you'll see what I mean when we work on those here in just a minute. Okay? Let's start with number 1 here on the check your understanding. If secant of theta equals 4, find cosine of theta, tangent of theta, sine theta, cosecant of theta, and cotangent theta. So given one trig identity, or not identity, but given one trig ratio, let's find all the other ones, okay, so that we have all 6 of them when we're done. And I'm going to add the little detail that theta is going to be in the first quadrant between 0 and pi over 2, okay, just for the sake of this problem. So what I want to do actually is I want to set up a right triangle in quadrant 1. So let's start by doing that. Okay, here's the positive side of the x-axis, the positive side of the y-axis, and our angle theta is right here. So since angle theta is right here, that means this is the opposite side of theta, this is the adjacent leg, and we know the hypotenuse is always across from the 90-degree angle. Okay? Now we were given some information to begin with. We were told that secant of theta equals 4. And since secant and cosecant are reciprocals, that means secant and cosine are reciprocals. Secant and cosine are reciprocals. That means cosine of theta is going to be 1 over secant of theta, which is 1/4. The reason this is nice is because now we can start filling in this triangle a little bit. I remember what we know from SOHCAHTOA. SOHCAHTOA. We know that the cosine of an angle is the adjacent leg divided by the hypotenuse. Since cosine is 1/4, that makes 1 the adjacent leg that makes 4 the hypotenuse. So 1 is the adjacent leg, 4 is the hypotenuse. We can find the opposite leg using Pythagorean's theorem. All right, so Pythagorean's theorem says leg squared plus leg squared equals hypotenuse squared. So 1 squared plus the missing leg, I'm going to call it b squared equals the hypotenuse 4 squared. 1 squared is 1. 4 squared is 16. This means b squared equals 15 when you subtract the 1. And when you take the square root of both sides, b, our missing leg, is the square root of 15. Now normally when we would take the square root like that, we'd have a plus or minus in front of the square root, but since we're putting ourselves in quadrant 1, we only need the positive 1. Okay? Now using this triangle, we can find all 6 trig ratios. So sine of theta, I'll start with that. Sine of theta, well, we know sine is opposite divided by hypotenuse. So opposite is square root of 15. Hypotenuse is 4. So sine of theta, square root of 15 over 4. Cosine of theta, we've already established, is 1/4. You can also look at the triangle and do adjacent divided by hypotenuse. And tangent of theta is opposite over adjacent, which would be square root of 15 over 1, which is simply just the square root of 15. All right, now let's look at the reciprocals. The reciprocal of sine of theta is cosecant of theta. So all we have to do is take the reciprocal for sine. Instead of square root of 15 over 4, cosecant would be 4 over square root of 15. The reciprocal of cosine of theta is secant of theta. And reciprocal of 1/4 is 4. We were also given this, so you already had that. And then for cotangent of theta, if tangent is square root of 15 over 1, then cotangent will be 1 over square root of 15. All right. Numbers 2 through 4. Simplify each trig expression so that the answer is either a number or one trig expression. Okay, so if you look at these trig expressions, like for example number 3 here, notice that we have 3 different trig expressions. We want our answer to be a single trig expression or a single number. Okay, so the goal is we're going to use all these different identities that we've established up here to simplify these things down. And one of the best beginner tips I can give you for simplifying trig expressions is to convert everything into sines and cosines to help make it a little bit easier. Okay, so let's go ahead and see how this is going to work. Looking at number 2, we have secant squared of theta times 1 minus sine squared. 1 minus sine squared. If we look up here, 1 minus sine squared is the same thing as cosine squared. This is that Pythagorean identity rewritten. Okay, so 1 minus sine squared is the same thing as cosine squared. So now this is going to turn into secant squared of theta times cosine squared of theta. Okay, now let's convert these things into sines and cosines. We know that secant of theta is 1 over cosine of theta, so secant squared of theta is going to be 1 over cosine squared of theta. Now cosine squared of theta, we're trying to convert things into sines and cosines. This is already in terms of cosine, so we can leave it alone. I am, however, going to write it as cosine squared over 1. Okay, there's an implied 1 underneath. Now notice cosine squared of theta in the denominator cancels with this cosine squared of theta in the numerator, and all we have left is 1 divided by 1, which is equal to 1. So this whole thing right here simplified to give us 1. All right, next, cosine squared of x plus sine squared of x divided by secant of x. This right on top, That's one of our Pythagorean identities. Cosine squared of theta plus sine squared of theta is equal to 1. So go ahead and replace that top with 1. We have 1 over secant of x. 1 over secant is the same thing as cosine. So this simplifies down to simply cosine of x. All right. Number 4, secant squared of x minus tangent squared of x. Well, this is our second Pythagorean identity rewritten. Secant squared of theta minus tangent squared of theta is simply equal to 1. Okay, so those are some pretty basic simplifying trig expressions. You'll get some that are a little bit more interesting in the homework. All right, number 5. Solve sine squared of w plus cosine squared of w plus cosine of w equals 1/2 when angle w is between 0 and 2 pi. All right, so first thing I notice, sine squared plus cosine squared, this is equal to 1. So now we have 1 plus cosine of w equals 1/2. Okay, so we simplified it down substantially. Let's go ahead and subtract 1 from both sides. Now we have cosine of w equals, well, 1/2 minus 1, that's -1/2. And now we're trying to find out for what angles w is the cosine equal to -1/2. So that's just going to be our unit circle knowledge, right? Cosine is equal to -1/2 at 2 pi over 3 and 4 pi over 3. So angle w is 2 pi over 3 and 4 pi over 3. All right, number 6. It's our final one. Yes, our final one. Which of the following is not equivalent to cotangent of beta? This is the Greek letter beta right there. All right, so which one is not equivalent? Let's look at each one of them real quick. Cosecant squared of beta minus 1. So this is using this trig identity right here. 1 plus cotangent, or this one right here. Cotangent squared of theta equals cosecant squared of theta minus 1. Okay, it's using that one. So here's what we have. Cotangent, or you know what, let's just go through the whole thing. Let's start with the original trig identity. So 1 plus cotangent squared of theta equals cosecant squared. So we have 1 plus cotangent squared of beta equals cosecant squared of beta. Subtract the 1 over. Cotangent squared of beta equals cosecant squared of beta minus 1. Then take the square root of both sides because we're trying to get cotangent of beta. So if you take the square root of the left side, you get cotangent of beta. And then we have square root cosecant squared of beta minus 1. So square root cosecant squared of beta minus 1 is equal to cotangent of beta. This one is good. All right. B, cosine of beta divided by sine of beta. That is literally the identity right here. Cosine over sine is equal to cotangent. So cosine beta over sine of beta is equal to cotangent of beta. So this one is also true. C, secant of beta over cosecant of beta. Well, let's turn secant and cosecant in terms of sines and cosines. So secant of beta is 1 over cosine of beta. Cosecant of beta is 1 over sine of beta. And what I'm going to do is I'm going to keep change flip. Keep the top, 1 over cosine of beta, times, change the division to multiplication. Now flip the bottom, sine of beta over 1. All right, 1 times sine of beta is sine of beta. Cosine of beta times 1 on the bottom is simply cosine of beta. But sine divided by cosine is tangent, not cotangent. So this one is wrong. All right, so that's going to end up being our answer. Let's real quickly look at the other one as well. All right, so cosecant of beta times secant of beta minus tangent of beta. Let's turn everything into sines and cosines. Cosecant of beta is 1 over sine of beta. Secant of beta is 1 over cosine of beta. Tangent of beta, sine of beta over cosine of beta. Okay, so notice here, this is going to give us, when we go ahead and multiply it, 1 over sine beta times cosine beta. Then we have minus sine beta over cosine beta. To get a common denominator, see how this has a sine beta times cosine beta, but this one only has a cosine beta? We're going to need to multiply top and bottom of this by sine beta. That way we'd have a common denominator of sine times cosine for both of them. Right? This will give us 1 over sine beta cosine beta minus sine squared beta over sine beta cosine beta. All right, continuing to simplify. Now condense this into one fraction. 1 minus sine squared over sine beta times cosine beta. 1 minus sine squared is one of our identities from up above. That's going to equal cosine squared over sine beta times cosine beta. And then notice cosine squared means there's 2 cosine betas. So this cosine beta is going to cancel with one of the 2 on top. Now we have cosine beta over sine beta, which is equal to cotangent of beta. So this one also worked. All right, what I'm going to do next, since the homework is pretty long and this is a very important set of notes, I'm actually going to make a video where I walk you through my key to the homework. All right, have a great day, y'all.